For the past century, transport modes have inspired filmmakers and fired the imagination of inventors. Take some horses, a set of wheels and human genius and you can move almost anything. It all began in the Belgian province of Brabant. In 1925, Frans Sarens, backed by his numerous family, set out to take up the challenge of industrialization. Later on, his sons invented the art and science of dimensional load engineering. Rubber tires replaced cartwheels and horses bowed out to the internal combustion engine, but no matter what the construction, assembly, loading or transport problem, a solution was always found. Today, the third generation of the Sarens dynasty has a global presence, and the group combines strategic vision and expertise with the entrepreneurial spirit, day in, day out. Building on a glowing track record, this family concern has now contributed its know-how to the greatest rail construction project of the late 20th century. To the south of Montélimar, the gateway to that Provence so loved by writers and artists, Sarens took the TGV Méditerranée line over the Donzère Canal. At La Gare d'Ademar, a rail structure to rival any of the 19th century's greatest steel achievements is put together with millimeter accuracy. After a 2-week voyage on the high seas and along canals, the components of this bowstring structure are brought to the site from their North European birthplace. The sections are unloaded using an 800-ton crane with a 42-meter mast anchored to a 1,200 square meter pontoon structure made from twin barges. In its bridge approach phase, the twin barge and crane are jockeyed into position using 4 winches pulling on anchors positioned upstream and downstream of the bridge. Positioning each 150-ton arc section calls for an expert eye and a sure hand. La Gare d'Ademar, a proud 5,000-ton metal structure testifying to a unique combination of daring and practicality that's already a part of our future. Further south, the 14th century fortress at Monas keeps watch over the Rhône and its history. A history wrought in water, light and steel. For the very first time in rail construction, a 2,500-ton bridge is to be moved into position from a riverborne platform. 120 meters long and 30 high, the bowstring is jacked up onto 5-meter-high pile piers, resting at either end on a series of remote-controlled self-propelled cars comprised of 48 axles driving 192 wheels. During the initial transfer sequence, the assembly is rolled along the assembly platform prolonged by a temporary landing stage built out from the river bank. All movement is continually checked by laser, with the convoy advancing at a pace of 2 meters per minute. Moving beyond the landing stage, the cars inch forward between the columns of the pier, clearing the upper part of the bridge supports. On reaching the Rhône, the assembly is moved aboard a twin barge pontoon structure moored at the end of the landing stage. To guarantee horizontal stability and a constant height for the load, the barges are deballasted as the cars move on to the pontoon. The river transport part of the operation can now begin. During the crossing phase, the front end of the bridge structure rests on the mobile pontoon, while at the other end, forward impetus is provided by the 4 self-propelled cars remaining on dry land. The barges are guided by 4 winches connected to 4 anchors positioned 300 meters upstream and downstream in the bed of the Rhône. In less than 30 minutes, the 112-meter distance is spanned with millimeter accuracy. After docking, the front cars are wheeled from the deballasted barge onto the reception pier. At Mornas, with SNCF's rehabilitation of the bowstring bridge, Sarras has achieved a genuine exploit. And the construction world was treated to a repeat performance when Sarras tackled another Rhône crossing at Mondragon. Mondragon, where as the summer glare softens into the mellower shades of a Provençal autumn, the Mornas Viaduct's twin is born. The 1,300 tons of the metal bowstring structure rest at either end on a series of 28 axles turning 112 wheels. During the first movement sequence, the metal structure, 23 meters high and 86 meters long, is moved over the 200 meters separating it from the loading pier. Automatically adjusting to the profile of the movement schedule, the system's hydraulic rams ensure that the bridge remains perfectly horizontal throughout the movement phase. Beyond the pier, the self-propelled cars immediately embark on a deck 10 meters above the surface of the river, positioned on the pile pier standing on the Sarras twin barge pontoon. The twin barge's tanks are gradually deballasted during the loading phase to ensure the necessary constant flotation level throughout the crossing. Once the front bearing assembly is in position on the deck, the river crossing sequence can begin. Compressed into just a few seconds here, the river crossing phase was cable guided. In less than 4 hours, the docking operation was completed with the help of precision laser guidance. Those self-propelled cars inch forward once more to gently deposit the front section of the bowstring onto the reception pier. As dependable as clockwork, Sarras ensures another record-breaking construction goes down in the annals of railway history. South of Avignon at Bompard, the former 12th century Carthusian monastery is the silent witness of a world civil engineering premiere, with the positioning of a 124-meter bowstring structure directly over the Avignon South toll forecourt. 448 wheels and 112 axles guided by a single remote control device are all it takes to position the 2,500 tons of steel. The remote control cars are positioned both at the bow of the structure over a 16-meter front and at the rear, and advance along a carefully planned trajectory. Front and rear motion are perfectly synchronized to align the structure before final anchoring on the docking supports. In just 4 hours on this 3rd of June 1998, Sarras masterminded a TGV Méditerranée sensation with its placing of the Bompard viaduct. It was here that Cézanne loved to paint on the motif, as he said. The creative genius of the artist is bound up with that of Franz Maillot de Montrichet, the 19th century architect of the Roquefort aqueduct, which carries the waters of the river Durance down to Marseille. Such a matchless sight deserved an outstanding viaduct. 416 meters long and soaring 20 meters above ground level, the Arc Viaduct boasts 7 44-meter metallic spans that make up its deck. Lifting preparations, trajectory planning and attaching the mooring systems are all part of the preliminary stages of the positioning sequences. At a rate of one 180-ton section per day, an 800-ton crane delicately places each deck section on its supports with razor-edge precision. Unrivaled expertise, perfect control, high-performance equipment, and personal modesty underpin every stage of this brilliantly successful operation. At Roquefort, bold vision and elegant design are combined by a pioneering company to build a viaduct for the 21st century. With its contribution to the TGV Méditerranée project, Sarras has left an indelible mark on civil engineering history. A new generation is poised to enter the third millennium.